Hello. So by 2050, 70% of the world's population is projected to live in cities. We are starting to evolve into an increasingly urban economy, and urban centers will start to adapt and evolve to meet the demands of these growing populations. From from an urban perspective, it could lead to economic growth. It can improve living standards, increase and improve cultural diversity. Here's some stats I want to share. The world's urban population has been rising almost sixfold since 1950, from 751 million to almost 4.4 billion people today that are living in urban centers. This is expected to continue with more people actually doubling in urban populations by 2050. Today, more than 56% of the world's population now lives in urban areas. So when we talk about increased migration to these urban centers, it can pose other challenges. So we will see accelerated demand for affordable housing with risks to potential overcrowding, pollution, maybe rising conflicts and social inequity. So this actually calls for more sustainable development to build the viable infrastructures, the transport systems, the basic services, the job opportunities to ensure that these cities are safe, they're inclusive, they're resilient, and they're sustainable. So enter intelligent city. And I'm going to bring both Oliver and OD to the stage. And so this company is based out of Vancouver, Canada, and they're founded in 2008 with a mission to empower people to live better urban lives. And so this company aims to streamline construction processes, standardize housing in an effort to actually create a commercializable and sustainable alternative. So we have the pleasure today to speak to one of the founders of Intelligent City, Oliver Lang, and OD Craig, who is the CTO, to discuss the future of increased urbanization and how this company is navigating their challenges towards a world where increasing sustainable practices becomes the norm. So welcome both of you.
Hi, Essie. Very nice to be here, and thank you for having us.
No problem.
Yeah, thank you for having us.
Thank you. Okay, Oliver, I'll start with you. Tell me about your vision for intelligent city and a bit about the journey that got you to where you are today.
Yeah. So we started Intelligent City to really address two fundamental issues that we start seeing in the world maybe already 20 years or longer ago, which is really the emergence of climate change issues on one end, on the other side, the lack of choice and the lack of supply of affordable urban housing. And then thirdly, also really the lack of adoption of technologies in particular in our industry. Like some have coined the term that we're sort of the construction industry, development industry is the last laggard who has not really adopted the powers of technology that's transformed pretty much all other industries. So yeah, it's about 15 years ago we looked at what we think should be done and how we want to approach it, and felt it was necessary to create a new company that would really take a very different approach to how we could get to these answers that we thought are really, those are global problems and that required sort of a highly scalable solution that could fit that sort of scale of problem that's there. And as you mentioned, with the urban population, I think many of you probably heard the idea that to meet demand by 2050, we have to build essentially a Shanghai or a New York City every month for the next 25 years. And if we want to do that, we have to do that, and we not want to leave a planet behind to next generations that is actually desirable to be on, and we'll have to really change the ways how we're conducting ourselves.
Sorry about that. I think I just muted myself. So, OD, you consider yourself a new generation of industrialized construction and in this advanced manufacturing platform on the route to more of a carbon neutral future. So tell me about a little bit about the overview of your platform.
Yeah, so construction, as everyone knows who has built a building, a house, or was involved in any of that remotely, is a pretty traditional and a very manual sort of workflow. Every building is a one-off building. Every building is a sort of a one-time project where many entities, many consultants and planners come together to design, engineer, and then ultimately build this building on a construction site. And that model has really not changed for pretty much hundreds of years, except that here and there some technologies have gotten hold. We are planning with computer software, but it is still a very sort of representational, hierarchical approach to delivering a building. And in any other industry, we are looking at products. We are looking at laptops, cars, and even ships. Anything larger even is a more productized approach, or has a more productized approach, which means that the engineering and the design and the planning of how it's actually being made is already done by the time a client comes and chooses a product, right? And in order for construction to move into that area, in order for construction to become industrialized, we need to productize. We need to think about a more holistic approach. What is the building made of? What does it need? How does it need to be pre-engineered and understood from design to manufacturing and to delivery on site to be more like a product? And if that is the case, if we can achieve that, if we can get to that paradigm, now we can scale up the production of housing. Now we can actually start to make housing faster and provide it in an easier manner, shortcut sort of that typical 2-3 year process of trying to figure out how things work, and until you end up with a building that is extremely unique. And so we looked at developing a platform that allows us to design buildings within that platform, from that platform, and customize them to the specific needs and the specific location of the building, although it all comes from that same platform. And by sort of bridging the gap between the scalability and the repetitiveness of a platform and the customizability that we need in our industry, we believe that we have a balance where we can deliver housing at scale. And that's really sort of the fundamental of industrialization, is now we can scale up, we can speed things up. But on top of that, the question is always, when it comes to construction, what kind of materials you're using. And mass timber is a very attractive material to use in an industrialized construction environment. Mass timber is anything that is thicker engineered timber. It's a specific description of thicker engineered plates and beams with which you can also build high-rise construction. And it is easy to use in prefabrication. It is easy to transport, and it is a sustainable building material. And now you're starting to put a lot of building blocks together where you can say, well, we can build actually in a much more sustainable way. We can make use of the resources we have in Canada, and we can deliver housing faster and at scale. And by doing so, also increase affordability of these buildings. And so this platform is sort of the fundamental of changing how our industry works. But you need to put together quite a lot of different puzzle pieces to make it work.
Okay. So you mentioned a couple of things there. And so what I'd like Oliver to do first is to explain a little bit more about mass timber and why that is, first of all, more sustainable, but like what exactly is it? And why not, like, why move away from the traditional metals, plastics, gypsum, asphalt, apart from the fact that they're not as sustainable? But why is mass timber more of your optimal solution?
Yeah, so we made a very, very conscious choice a long time ago that we would use mass timber as the almost the foundations of everything that we use, for a number of reasons. A, It comes from a renewable resource, a resource that, as you know, when trees grow, they sequester carbon, they store carbon. And so you, instead of having a lot of carbon emissions, let's say when you do a concrete building, in the embodied carbon footprint, so everything that goes into the building, the construction of a building, with a timber building, you actually not emitting, you actually do the opposite. You're actually using a material that has embodied carbons now sequestered into it, and is a more sustainable solution from that perspective. Further, it's against the understanding that a lot of people have is structurally actually extremely strong, because in mass timber, other than in stick frame that many people refer to as timber construction, in mass timber, you're cross-laminating things together in an engineered product that's extremely strong and dimensionally stable. You get to something that is fire resistant. If you ever try to put a match to a log on a campground, you know that you can't set it on fire. You need kindling wood, but with mass timber, you can get to that. So we have structures right now that are completely fully exposed timber structures and that are 2-hour fire rated, 2-hour fire resistant, right? Again, so that's a bit the revolution in this. And then there's a whole biophilic aspect, which means people actually love living with natural material and be surrounded with something that's more sustainable. But maybe most importantly for us at the end was a decision. We wanted a natural material that allowed us to bring together this natural resources with the powers of Industry 3.0 back then, or Industry 4.0 now. It is entirely machinable, millable. We can use industrial robots right now to machine this material to precisions of a millimeter or further, and then assemble through advanced fastening, gluing technologies and so forth, very large building systems from it, right? So it's almost a dream material to industrialize in our sector that didn't exist before. And then beyond that, what's been really exciting is, and we've been working on this for a long time with regulators and so forth, but that now the building codes over the last few years have been adopted, that mass timber construction across the North American continent, in most of the states and many of the Canadian provinces, we're allowed to build up to 18-story mass timber buildings now under the building code, and under a more and more unified building code that allows us so that we can scale across what you can do in other industries, right? A reliable, predictable regulatory framework, and so many advantages by using this material that is really the foundation for almost everything that we do.
Now, can I ask either of you, like, if you start to compare even the process of traditional construction with what you're doing, what is the difference in time to market?
So time to market, in terms of, if I can clarify your question, time to market in terms of how long does it take our product to reach a construction site?
Yeah, just fully, probably, yes, I would say that.
Yes, yeah. So there are a number of options for us where we can reduce the total time of construction by up to 50%. Because first thing we're doing is what the prefab industry's done for some time right now, that we're basically, while we're manufacturing in the factory, other people advance things on site, and you essentially get parallel construction, right? And so that speeds things up. But beyond that, you can also get to a point where you can get approvals faster, which has always introduced a lot of uncertainties, right? So when you combine that possibility of fast approvals on development permits and building permits, because you've productized, because you have certified solutions, right? Which is what we do, right? So we don't just do a one-off solution for that project. As Odie mentioned, we go through a full program of testing, prototyping, testing, and certification, so that we can use it across a whole number of projects. So we don't innovate on the back of a single client. We actually don't innovate on the back of clients. We create a product and we deliver it to market so that it can be deployed rapidly.
Okay. I wanted to add some stats here because I think one of the reasons why you're looking at a more sustainable solutions, because the traditional construction industry does actually lend a lot in terms of, generate a lot of waste. Canadian Construction Association indicated almost 9 million tons of waste annually in Canada. And the waste management industry, this was 2018, it's quite old, but they indicated that the construction sector accounted for almost 25 to 30% of the total waste generated by all industries. So from your perspective, how much are you actually saving, do you think, or reducing in terms of waste?
Go ahead, Oliver.
There is a significant saving or reduction on the waste side, because when you productize for a building, you basically lay out all the systems in a way that they're most materially efficient, right? We precision machine everything for that particular component, and we're trying to have as absolutely as little waste as possible, and other than some sawdust, call it, right? That from the machining itself. So that's the waste reduction on that end. I think that's very, very powerful. The other one is to optimize buildings overall to really be materially efficient, so that the layout of buildings, the form of buildings, the way how they fit in the urban environment, everything is done around really highly optimal design and engineering principles, so that design and manufacturing are brought together. They're not, one is an outcome of the other, but we call it, design for manufacturing. And that's, I think, a thing, again, that it's done in many other industries, but it hasn't been done in the construction sector.
Okay.
Yeah, and if I can add to that, I think prefabrication in general moves a lot of the making of a building from a very chaotic environment to a planned environment, right? And the reason why construction is adding so much to waste is because it is a very chaotic environment. It's not very controlled and not very planned ahead. And so you do have, simply because of all the trades working on site and not coordinating very well, you just generate a lot of waste because of that. But of course, you also create much less quality because of that, right? So it is literally like taking the pre-Ford era making of cars from sort of a very custom, manual, one at a time approach to an industrialized approach, which obviously has a lot of things have to change when you do that, right? But one of the effects is that you reduce waste. And mass timber is great in a sense because it is wood. And so even the wasted wood can be reused. It can be used for energy generation. It can be recycled or even upcycled sometimes. And so there is a lot of that. We are creating basically an ecosystem here of using the natural resources that we have in a sustainable way. And of course, we have to also, maybe as a side note, we have to use sustainable forestry to actually do that. But then the wood that we are using and that we are consuming and the waste that comes out of it can also be reused and ultimately create a much more sustainable construction industry.
Okay, thank you. I'm going to pivot a little bit because we're starting to talk about how the world is increasingly going to be more urban centers. And so intuitively, once we start to see increased migration to urban centers, we would assume that we're going to have increase in densely populated areas, that it's going to increase the demand for materials, for energy. It will drive up cost of housing. It will impact the quality of life and even affordability. And also, let's not forget that we actually have the risk of increasing CO2 levels in more urban areas as we get more people into these centers. So, Oliver, could you respond to some of these risks of urbanization, the effects of greenhouse gases? Let's take one of them at a time, like heat islands, for example, where rising temperatures in surrounding areas can be exacerbated because of the effects of global warming more at the local level.
For sure. Yeah. So I mean, the issues in impact of climate issues like heat island effects and transportation issues and everything that really we're dealing with in cities right now. There are strategies to counteract these, right, and that ultimately create an urban environment that has more green spaces, buildings that are really far more sort of intelligently integrated from a design perspective to allow to counteract these effects, right? And so this goes back to design, engineering solutions. This goes back to landscaping. This goes back to different pavements that you use to allow for absorption of water, and counteracting like heat island effects and so forth, to make sure that buildings function with low energy needs, so they don't give off a lot of heat because they're designed really highly energy in very many ways, with low energy needs, low cooling and heating needs. They don't overheat by design. If you look right now in urban landscapes, many of the buildings are just glass towers with very, very low insulation value that dramatically overheat on one side of the building. And the only way to keep them cool is to running mechanical systems that then give off a lot of heat and a lot of energy in return, right? So what can we do? How do we address that? What can we do to, so we optimize? So maybe I want to sort of back up for 1 second here in the definition of, because I don't think we have explained that sufficiently, that we're really, as a product company, we're design and engineer buildings, and we bring together these mass timber building systems. We bring advanced manufacturing, automation, robotics together with advanced software. And all of that allows us to actually sweet spot buildings in ways that you couldn't before. So it's very, very powerful to look at the energy consumption of a building when you go through optimization. You can look at the construction costs. You can look at the carbon footprint from a number of different perspectives, from the embodied carbon to the operational carbon, and you can find that optimum between the effect that the building has on the environment, the effect that the building has from a cost perspective, in the cost of construction, the cost of operations, and so forth. So the discussion about the environmental impacts become also one of affordability, what I've said at the beginning, right? So dollars and cents, they're not contradicting each other. Then building environmentally sound and carbon neutral doesn't mean it has to be more expensive. In fact, if you do it right, it becomes more affordable, because you don't unnecessarily heat the world around you. You're actually only heat and cool for what you need, because you're creating a proper envelope. You don't unnecessarily waste materials and build with carbon intensive materials that require a lot of labor that we don't have available. We actually use a material where we can get industrialization at scale, right? And so these things are all interconnected in so many ways. At the end, our sector, our industry, is directly responsible for 40% of carbon emissions. And if you add to it the way how we plan cities and how poorly we plan cities force people into cars, then we're all of a sudden over 60% of carbon emissions.
Mm-hmm. Mm-hmm. That actually is a good segue, because I'm going to ask Odie this question about, so now you have people moving into these beautiful places. Can you actually help control energy efficiency now that you have more people in these urban centers and there's going to be increased mobility?
Well, it's a very multi-layered question, because on the one hand, if we look at our current cities, we see evidently problems of mobility, right? So if you keep everything as is and you only change one variable, you will probably not really get to a more efficient or a more sustainable urban infrastructure. On the other hand, if you think about what happens if you change the way a city is laid out, or you change the way how dense a city is, you can actually at the same time increase its efficiency and sustainability, because naturally certain demands will emerge, right? So the problem that we have in many North American cities is that we have this stark contrast between very, very dense urban centers and very, very low density around it with single family housing. And so you have in the single family housing areas, you have too little density to actually to make sense for public transport or other public infrastructure to be in these areas. You have too few people in that area to really have, for example, public transport. So if you increase the density to a certain level, you can create an environment where you have public transport, but now you also have enough density to simply naturally create communities where people don't even need to travel that far anymore, right? So that's kind of the idea of the 50-minute city. You have enough density for enough people to be in a 50-minute radius. So you have all the stores, you have everything that you need. Plus you have enough density for public transport to also make sense. And now these people can move around without needing a car. So you kind of have these compounding effects, but you need to increase the level of density to a certain extent. However, you don't need to increase the density to have 60-story towers. That's also completely miscommunicated, because that level of density actually doesn't help us, and it makes our cities, it kind of increases that level of heat islands, and you don't have enough space for even greenery to be planned in these cities. So you need to have a sort of a middle way, and that middle way is what many talk about when they mention the missing middle, which is sort of the 4 stories to 8 stories or 12 stories construction, where you have enough density for all of this stuff to make sense, but not too much density. So you still have a very healthy city. And then mobility and energy consumption is the most efficient. And I think that's sort of a trajectory where our cities haven't really gone yet. And for the most part, it is because steel and concrete construction are very efficient when you build really, really high. Especially concrete gets really efficient when you build 40, 50, 60-story towers. And it's not very efficient, not very cost competitive when you build 8-story towers or 8-story buildings. But that's exactly where mass timber is perfect. Mass timber is excellent for 8, 12 stories, up to 18. And that's where it's cost competitive to concrete and steel. So you can actually build for less money, and at the same time you also build a much better building and a much more sustainable building, and you incentivize that cities become more sustainable and sort of become a more healthy environment.
If
Now,
I might just add one point there. When you look at North American cities, they've sprawled so much that many of the city centers have actually reasonably low density. You walk around, maybe other than Manhattan or so, but most North American cities have long avenues, long corridors of 1, 2, 3-story buildings. And all these buildings are perfect for densification. And that is what's happening right now. There's like 3 things that's starting to align. One is the trend that people don't want to commute and spend their days in cars. They want the 15-minute city. Cities are realizing, and they're upzoning these urban arteries so that you can put in 8 to 12-story buildings in the future. And then, as I mentioned, you have this new building code that now allows to do that in timber construction. Because before, if you wanted to build an 8-story building in concrete, let's say, it's not the scale at which concrete construction is really efficient. Concrete shines above 20 stories, 25 stories, where we really have the repetition, where it's more cost effective. And so we have all of a sudden the tools available that we can densify our cities within the boundaries of what's there, and then, as Odie mentioned before, then really take advantage of public infrastructure investments for rapid transit and schools and anything you need to have a vibrant city. And there are many examples around the world where that has worked historically. That scale of sort of 6, 8, 12 stories, most of Tokyo is that scale. It's the most populated city in the world, with over 30 million people, and functions extremely well at that scale. The city of Barcelona is a beautiful example that has that density for well over 150 years now. And so that's an opportunity right now. And again, the new set of regulatory frameworks and development of technologies that we're working on opens up that opportunity.
do you think that, because I know we're headed this way because we have to, based on the Paris Accord, but as you're building for this new type of, I guess, environment that is our future, how do you see policy changing to reduce emissions when it comes to energy consumption, or even just to promote more sustainable practices? Because I'm assuming that what you're building will enable better habits, better practices from the people that live there. But it's still going to take time for people to transition to this new way of living?
Yeah, I mean, we definitely, I mean, at least in our environment in Canada, we see a lot of policy change to enable, the biomass sector. So, timber construction is of great interest to Canadians, and I think to people in North America across the board, that you can use an activated renewable resource that right now we don't add any value to. We just turn into pulp, right? And yet trees, forests are really in many ways a way to solve this problem. How do we build housing for 4 billion people on this planet? And so I think that realization has started to come in, and so has energy efficiency, right? Really, if you make buildings far more energy efficient, now all of a sudden you have this moment where things switch, because now you can use alternative forms of energy. You can use, ground source heating and cooling. You can use heat pumps. You can use solar, because you just don't need that much energy on a per building, on a per home basis any longer. And so it changes that. And I think regulators have come into to understand now, and they're incentivizing. So you can get, for example, in Canada right now, much better lending terms underwritten by the federal government if your building meets so-called passive house standards, so a 90% reduction of energy needs on a building. And you can get additional density in cities, for example, in Vancouver, for example, was just released. You can get another 20 or 25% extra height and density if you build in timber. And we've heard from some cities now they're incentivizing as high as 50% additional height and density. So it creates an incentive on one end, and then regulation, as I mentioned, from a building code to development bylaws, also provide far less hurdles to adopt really these new technologies.
Okay, thank you, Oliver. Okay, I'm going to throw the last question at OD. Intelligent City is the name of your organization, but Canada is still actually, I guess, wrestling with building its first smart city. And I assume where you are is probably going to be in Vancouver. But from your perspective, what are the lessons that we can learn from Sidewalk Labs here in Toronto? I don't know. I think it was less than 5-6 years ago, to create an environment that really works for its citizens.
Yeah, we work in Toronto too, actually. So this is definitely an important question. Sidewalk Labs try to build a smart city neighborhood with a heavy focus on data collection and using that to make the neighborhood, more efficient, definitely. But I think what led to a lot of pushback is the idea that a single company would hold a lot of data. And I think that is something we will have to consider as our buildings and our cities become smarter or more intelligent and more interconnected. I think there are many, many reasons why we want to have data collection. If you look at a single building, I think a single building is a multifamily building it would be very beneficial for that building to collect information and to know about, for example, at any given point, how many people are currently at home, how many people have their windows open, how much heat or how much cooling is needed in that building, how much energy do I need to take from the network, how much energy can I maybe produce if I have solar panels on my roof. There's a lot of data that can be managed, even for maintenance, right? Lots of sensors can be used and the data can be interpreted to understand if any maintenance is coming up or if anything is going to fail. That's also where AI comes in, I think. A lot of that sort of data collection, big data interpretation of what's going to happen to this building. But then, of course, on a city scale, you want to also understand or communicate between different buildings. I think especially as the overall energy consumption of buildings gets reduced, the energy creation on buildings, such as solar panels or in the ground, can actually be shared between buildings, and we can create a network of energy sharing and brokering. But of course, cities also might want to understand if they can introduce more intelligent transport solutions. So, for example, what's the current demand on public transit? Do I need to increase the number of buses or trains, or decrease them to save energy? So all of that ultimately gets us to a more efficient and more sustainable infrastructure and better buildings and cities. But the data has to be anonymous. The data has to be not held by a single company. It has to be shared. It has to be completely anonymized. And I think we need a big framework, and I think that's where policy comes into a data framework, a data infrastructure, where these things can be communicated in a safe and reliable way and not be exploited for making specific decisions for a company to make more money out of it, rather than actually helping the city to become more sustainable.
Thank you. That's a very good answer for someone who's actually addressing somebody who's a privacy nut. So, okay, so that's all we have time for today. And I thank Oliver and OD from Intelligent City for joining us. I look forward to a future where people can live at this convenience of the smart city. It's more resilient, it's more sustainable. And these days, especially with rising inflation, it's more affordable. So, Tech Uncensored, by the way, is powered by Altitude Accelerator and produced by Bluemix and Transistor Radio. My name is Tessie Jones. And until next time, everyone have fun and stay safe.